You're listening to the N2K Space Network.
And now, a word from our sponsor, SpyCloud, the cybercrime analytics leader. SpyCloud disrupts cybercrime by telling you what criminals know about your business and your customers, so you can take action to prevent ransomware, session hijacking, account takeover, and online fraud. SpyCloud constantly recaptures and analyzes new data from the criminal underground, including credentials, session cookies, and PII siphoned from malware-infected devices. With knowledge of the specific exposed data criminals have in hand from InfoStealer malware on managed and unmanaged devices, security teams can respond with a more efficient and effective process called post-infection remediation that fits seamlessly into existing incident response frameworks. Get SpyCloud's post-infection remediation guide outlining the 7 steps for preventing a malware infection from becoming a full-blown ransomware incident. Visit spycloud.com/cyberwire. That's spycloud.com/cyberwire. And we thank SpyCloud for sponsoring our show.
The U.S. nonprofit group, the Space Foundation, says the global space economy grew 8% to $546 billion last year and is projected to climb another 41% over the next 5 years. You know, we've been cautiously saying that the space investment outlook is looking rosier, and if today's headlines are anything to go by, then it's looking like the industry is about to relaunch.
T-minus 20 seconds to LOS T-dress. Go for deploy.
Today is July 25th, 2023. I'm Maria Varmazis, and this is T-minus. Impulse Space raises $45 million in an oversubscribed Series A round. NASA Tipping Point program awards Astrobotic $34 million and Blue Origin $35 million for lunar projects. ESA awards Spire Global 16 million euros for their Euralio project. And our guest today is Dr. Tan Zhu, Assistant Professor of Mechanical Engineering at the National Yangming Chiao Tung University in Taiwan. Stay with us. Here's your Intel briefing for today. We're kicking off our show today with a lot of financial news. A whole bunch of companies have more money coming their way, so let's take a look at what's happening. Firstly, space logistics firm Impulse Space announced yesterday that they've raised an oversubscribed $45 million Series A round, which was led by RTX Ventures, with Founders Fund, Lux Capital, Airbus Ventures, and Space Capital also participating. Impulse Space has been working on last-mile orbital payload delivery services for smallsats, and this new funding will help support its LEO Express 1 mission, which will launch its high-thrust chemical propulsion orbital service vehicle called Mira, expected to launch at the end of this year in Q4. They're also developing the Helios delivery vehicle, which will deliver missions to geostationary equatorial orbits. Next up, recipients of the NASA Tipping Points program for 2023 have been announced today. Through Tipping Point, NASA is seeking to support space technologies that can foster the growth of commercial space capabilities and benefit future agency missions. Astrobotic has been awarded $34.6 million through the NASA program to demonstrate power transmission on the lunar surface. The Pennsylvania-based company says that the award will result in a demonstration on the moon called Lunagrid Light, which will transmit power from a lunar lander to a tethered rover. And another recipient of the NASA Tipping Point funding is Blue Origin. The company's been awarded $35 million for their Blue Alchemist program to produce scalable solar power systems from lunar dust. Blue says the investment will result in a demonstration of autonomous operation in a simulated lunar environment by 2026. The European Space Agency, or ESA, has awarded Spire Global a 16 million euro, or equivalent of 17.6 million US dollars, phased contract for the Euralio project. Now, ESA's Euralio project aims to determine the exact position of an airplane by geolocating its radio frequency signals. The idea is to provide an independent assessment of a plane's location to complement today's surveillance systems, which often rely on self-reported positions of aircraft derived from the Global Navigation Satellite System. Now, Spire will develop the mission and system design for an operational satellite constellation and then design, deploy, and operate a demonstrator mission that proves the performance of the service and its critical technologies. London-based company SpaceDots has raised 1.5 million US dollars in pre-seed funding. The space startup aims to accelerate materials development and mitigate mission failures. SpaceDots says that capital from the round will go towards commercializing the startup's first product, the Barnacle Dot, a material testing module that works in orbit. The smartphone-sized payload claims it can reach any orbit and can ride share on any platform, kind of like a barnacle, enabling customers to test materials across all space environments. Maxar Technologies has completed the first critical design review of the Maxar 300 series bus for L3Harris Technologies. The mission is in part of the Space Development Agency's Tranche 1 tracking layer program. The program is designed to provide warning and tracking of conventional and advanced missile threats, including hypersonic missile systems. Maxar's new satellite bus is designed for 8 or more space vehicles per launch. Maxar is currently in the process of building 16 satellites for L3Harris. In-space logistics startup Adamas Space have announced that they plan to launch 2 internally designed and built spacecraft on SpaceX's Transporter 10 in the first quarter of next year. Adamos say the vehicles, Quark and Gluon, will perform rendezvous, docking, refueling, and orbital transfer during their maiden flights. The demonstration mission aims to validate Adamos's Quark orbital transfer vehicle, which they hope will provide in-space services such as orbit raising, satellite life extension, cargo delivery to space stations, and refueling. It's not unlike us to discuss delays in space. After all, it is an inevitable part of space timelines. In this incident specifically, we're going to be referring to a delay in the first Space Training and Readiness Command, known as STARCOM, exercise. Space Force's orbital warfare exercise, called Red Skies, was due to be held this summer but has been pushed back until later this year. There's no official reason for the delay, but it comes hot on the heels of the first change in command for STARCOM. You know, it's been a while since we've talked about what's happening on the ISS, so we were happy to see NASA's blog post that listed what the Expedition 69 crew are working on this week. It's easy to forget that while we go about our everyday lives here on Spaceship Earth, there's a crew orbiting the planet at a mere 17,500 miles per hour, working on incredible science experiments that this week span genes in space, as in our human genes in the genome and not the fashion item, human health research, robotics work, and space station maintenance. The theme for a lot of the work conducted on board this week, which was water in space, is, after all, an essential for all space travel and, dare I say it, life. NASA astronaut Woody Hornberg installed a carbon analyzer that determines the quality of recovered water aboard the orbital lab and performed maintenance on the oxygen generation system, which converts water into oxygen and hydrogen from the water recovery system. We're sure that experiments on water recovery will continue as humanity keeps pushing towards missions to the coveted lunar South Pole, where ice is believed to be in the lunar craters. And the Experimental Sounding Rocket Association, ESRA, and Spaceport America have announced the dates for the 2024 Spaceport America Cup, the world's largest student rocket competition. Now, T-Minus covered this event in June of this year, and we will be there again June 17th to June 22nd, 2024. Now, each year, over 150 university teams from across the USA and around the world compete at Spaceport America's vertical launch area. Competing teams design, build, test, and launch their rocket with a payload size of 8.8 pounds to target altitudes of either 10,000 or 30,000 feet. Rockets are typically 4 to 8 inches in diameter and range between 8 to 20 feet long. Multi-stage rockets in all chemical propulsion types, solid, liquid, and hybrid, are allowed. We would love to see more companies and more teams at next year's event, so check out soundingrocket.org for more information. And as always, we've added links to all the stories we've covered in today's show and included some that we didn't for your selected reading, including a piece on SpaceX creating holes in the edge of space. Yeah, it's an exaggerated headline to say the least, and likely Alice's topic for the weekly team talk on this Friday's show. But until then, check out that story and much more at space.n2k.com. Hey T-Minus crew, if you're just joining us, be sure to follow T-Minus Space Daily in your favorite podcast app. And also, could you do us a favor? Share the intel with your friends and coworkers. Here's a little challenge for you. By Friday, show 3 friends or coworkers this podcast. A growing audience is the most important thing for us, and we would really love your help as part of the T-Minus crew. Thank you.
This episode is brought to you by Palo Alto Networks, the leader in cybersecurity. As AI-driven attacks increase, organizations can't afford to have network security that's stuck in the past. Discover how Palo Alto Networks can help you predict what's coming and proactively secure against it with a zero-trust, AI-powered network security platform built to secure whatever, whenever, wherever. To learn more, visit paloaltonetworks.com/network security platform.
Our guest today is Dr. Tan Zhu, Assistant Professor of Mechanical Engineering at the National Yang-Ming Chiao Tung University of Taiwan. We were introduced to Dr. Tan Zhu, who was mentoring the rocket team Formosan Fox from Taiwan at the Spaceport America Cup. I started off by asking Tan Zhu about what he does and what involvement he's had in Taiwan's student rocket team.
I'm an assistant professor in the National Yang-Ming Chiao Tung University of Taiwan. And here I mainly lead a lab that focus on designing aerospace systems like sounding rockets or high-altitude balloons. And also at the same time to use these systems for testing aerodynamics, doing aerodynamics research. I've kind of founded the student rocket team right here that is called Formosan Fox. And that became the first team from Taiwan to participate in a huge international competition like SA Cup. Formosan Fox right now is in its second cohort, and we have about 30 plus students right now across 4 different universities. But before that, we actually started as a pretty scrappy team, a small team of just 10 or 11 students, all mostly from the Department of Mechanical Engineering, with some from the Department of Media and Technology. So it was a pretty small team that really formed together during the registration period of SA Cup 2022. So let's say October 2021. But before that, we kind of started as a sort of a capstone program in the mechanical engineering's department.
We were hoping maybe this year we would see you, but it didn't end up happening. Thoughts on what happened this year and maybe what will be happening going forward for the team?
Yep, this year was kind of unfortunate for us, but it is mostly due to, I think, underestimating the logistical aspect of such an undertaking. With things like rocketry, we put a lot of focus on the technical aspects like the propulsion, and especially the propulsion because rockets makes fire and all that.
It's the fun part.
It's the fun part. But really, I think in addition to propulsion, the logistics takes up at least as much as the technical aspect of it. And I think we just didn't put enough people on it. And we also underestimated, the logistics after the competition. So not just prior to that, but also after that, when it is about time to, file all the paperwork, get those reimbursement back. That took us a long time. And it just wasn't enough time for us to regroup and re-enter into the next year.
I've heard that a lot from a number of teams. And I think for any listener who might be based in the US, we may underestimate how much of a humongous barrier that is. The logistics are not a small problem. And they can be very burdensome to teams. So I appreciate you saying that, because it's we have heard that quite a bit, and it's quite tough.
Yeah, so the advice is really to put half the team on logistics.
Oh, jeez. Which I'm sure the team is going, but that's not the fun part. I don't want to be dealing with that. But it's sort of like that's the reality of this kind of thing, is that has to be handled.
Well, maybe there is a chance to branch out from just, engineering students to also students from business management and that sort of field. It is an opportunity to branch out. It is worth talking a bit about the original inspiration behind the SA Cup attempt. The inspiration of it, I think, really came from the idea of Joseph Campbell's hero's journey. I don't know whether you are familiar with that.
Wow. Yeah, I am, but it's been a very long time since I've thought about it. Okay, so for our listeners who may also be going, it's been a while, can you give me a little summary of what that means?
So the idea of the hero's journey, it is a concept proposed by Campbell when he surveyed mythologies and stories across different cultures in the world, and also between really ancient stories and modern movies. He found that among all the most popular stories, there's a common thread, a common motif that tie them together, which is about how a person step out of their comfort zone, go onto an adventure, to willingly accept the adventure, and through challenges on those adventures, to really transform and grow as a person. So regarding how this idea inspired the program, I think personally for me, the most valuable learning experience I had was during my PhD back in Georgia Tech, where we were really pushed beyond our comfort zone and our limit. And I think that allowed me personally to grow a lot. So when I got here as an assistant professor, it became a question of how do we simulate, how do we recreate this in a more controlled and more rewarding manner for students. And from there, SA Cup just seems to be the perfect opportunity. It even incorporates the idea of a journey from Taiwan to the US.
Literal journey, yes.
Literal journey, yeah.
Those logistics can be tricky for heroes of all kinds, though. So that is what a great idea, tying that in. I mean, the whole archetype of the hero. When we're talking about these difficult things, it has to come from somewhere within like that to really get you motivated. So that's very smart.
It has to be a real challenge, I think. Yeah, I think learning, it shouldn't be from an examination kind of challenge where the answer is there and just hidden from you. So with SA Cup, I think the most precious thing about SA Cup is it creates an environment where you have to deal with actual real problem. Those who win on the launch site, or those dehydration in the desert, those are pretty real.
Let's talk a little bit about the rocketry program that you're working on, and also maybe the context within sort of Taiwan's larger, very fast-growing field of space launch and rocketry in general. So can you talk a little bit about that for me?
I guess just let me paint a picture regarding rocketry, at least within our universities. So within our school, there's really three tiers of rocketry right now. We have, for Mosan Fox, the SA Cup team being the more sort of entry-level, student-oriented team. Pretty free reign, and they can design any systems of their own. And then we also have a further tier, which is a research sounding rocket, where we are developing things that goes, maybe Mach 1, 1.5, things that are perhaps 500 pounds, to use the US unit systems.
Yes. You don't have to, but I appreciate that. That's very kind.
Yeah, it's like 500 pounds and 6 meter. What is that? 6 times 3, about 18, 20 feet-ish. Yeah, so much bigger rockets using more complex propulsion like hybrid rocket engines. Yeah. So that's the second tier, the research sounding rockets. And then we have a further tier beyond that, which is mainly manned by a research center with a much longer heritage, maybe up to 10 years of heritage at this point, I think. It is called the Advanced Rocket Research Center, or ARRC. It is actually one of the biggest rocket research groups within Taiwan. And with them, their heritage is mainly hybrid rocket engines. And so far, they have done active guidance with those engines, and they have even done a hovering flight with that. So that's the highest tier with technologies that are closest to the industrial applications level.
So when students graduate from your university, and do they have ambitions of, as we were saying, that maybe right across the street, or maybe not literally, but Taiwan's space program down the way? Like, is that where they're heading to next?
We really hope they do, because recently the Taiwanese Space Agency, which used to be called the National Space Organization, NSPO, it recently changed over to Taiwan Space Agency, or TASA. With that change, it not only strengthens the heritage in satellite programs like Triton or Formosat, but that change also added a completely new aspect, which is the development of a national launch vehicle. At least according to the public news, they are trying to get a orbital vehicle flying as early as 2026. So that's pretty fast-paced, which means they would really need a lot more engineers pretty fast. And if you look on the TASA's website, they have been hiring pretty aggressively. So definitely students that graduate here can, I think, really find a good continuation of their skills at TASA.
Thinking really broadly now, and I know this is just your opinion.
Yep.
What are you excited about in terms of Taiwan's space program? Like, what are you looking forward to? What's got you really, like, what are you talking to your students about when you kind of chit-chatting about what's going on in Taiwan?
I think the main things that is really cool is how fast everything's happening. In the US, you do have companies like SpaceX that is moving pretty fast in the new space industry. Aside from that, the heritage is kind of matured and fairly, the mass is fairly big, I guess, and it is somewhat harder for a single person to make a significant change on average, I guess. In Taiwan, it is a lot smaller. The size of the industry is a lot smaller, and it is just starting to get into launch vehicle development, although there has been past research in hybrid rocket and the like. So right now, if you are a really capable engineers, highly motivated, there's a lot of opportunity to make huge difference, like a historical kind of difference.
That's not every day people get that kind of opportunity. Thank you so much for walking me through this. I hope we see your team next year at SA Cup. I'll be rooting for you. Thank you so much for joining me today. We'll be right back.
Now, a word from our sponsor, the Johns Hopkins University Information Security Institute, currently seeking qualified applicants for its innovative Master of Science in Security Informatics degree program. Study alongside world-class interdisciplinary experts and gain unparalleled educational, research, and professional experience in information security and assurance. Interested U.S. citizens should consider the National Science Foundation's CyberCore Scholarship for Service program, which covers tuition and a $6,000 annual professional development allowance, as well as providing a $37,000 additional annual stipend. Apply for the scholarship and the fall semester by March 1st. Learn more at cs.jhu.edu/MSSI.
And welcome back. It's one of those pub trivia questions I bet at least a few of you know. Okay, so pop quiz. Which rock god is also a PhD in astronomy? Or perhaps I should rephrase, which PhD in astronomy also happens to shred like nobody's business and wrote some of the most famous rock anthems of all time? Why, that would be, drumroll please, Dr. Brian May of Queen, of course. 3 points if you got that one. Now, I don't think you can get much cooler than Brian May, who, amongst his many scientific accomplishments, has now also added co-author of a book of 3D photographs of the near-Earth asteroid Bennu. May's book contains images gathered by NASA's OSIRIS-REx spacecraft, which took samples from the asteroid back in October 2020. The rock star astronomer is said to be interested in stereoscopic photography. And of course, you know what that means, right? No? Oh, me neither. Not off the top of my head anyway. It's photography that simulates the ability of human eyes to perceive space in 3 dimensions. The book, Bennu 3D, Anatomy of an Asteroid, is due to be released this Thursday and is described as the first ever 3D atlas of an asteroid. It promises to tell the story of the fascinating space rock in a way that even non-specialist audiences can understand. Space rock meet rock god who will absolutely rock you. You know it's going to be an instant hit in the charts. That's it for T- for July 25th, 2023. For additional resources from today's report, check out our show notes at space.n2k.com. We're privileged that N2K and podcasts like T- are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. This episode was produced by Alice Caruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Brandon Karpf. Our chief intelligence officer is Eric Tillman. And I'm Maria Varmazes. Thanks for listening. We'll see you tomorrow.